Question DS. If m and n are positive integers, what is the remainder when 3 to the power of whole 4 times m plus 2 plus n is divided by 5? Condition 1, m equals 1. Condition 2, n equals 1. Solution. Let us solve this DS question using the variable approach. Remainder question after division by 5 or 10. If a question asks for the value of the remainder after the division of a term containing an exponent, p, by 5 or 10, then the remainder can be found by direct computing, as the units digit repeats after every fourth power or second power. Units digit 3. The digit 3 repeats after every fourth power, that is, 3 to the power of 1 equals 3, 3 to the power of 2 equals 9, 3 to the power of 3 equals 7, 3 to the power of 4 equals 1, and 3 to the power of 5 equals 3. Thus the pattern of the remainders when divided by 5 is 3, 4, 2, 1, 3, 4, 2, 1, and so on. Also, the pattern of the remainder when divided by 10 is 3, 9, 7, 1, 3, 9, 7, 1, and so on. Let's apply 3 steps of variable approach. Let us follow the first step of the variable approach by modifying and rechecking the original condition and the question. We are required to find the remainder when 3 to the whole power of 4 times m plus 2 plus n is divided by 5 for positive integers m and n. Now, let us modify the original condition based on the property we have learned. Now 3 to the whole power of 4 times m plus 2 plus n divided by 5 will leave the same remainder as 3 squared plus n divided by 5, since 3 to the whole power of 4 times m plus 2 equals 3 to the power of 4 whole power of m whole times 3 squared equals 81 to the power of m times 3 squared equals 1 times 9 equals 9. It is so because after the division of a term containing an exponent by 5 or 10, the remainder can be found by direct computing, as the units digit repeats after every fourth power. When we divide 9 by 5, we get 4 as the remainder, since 9 equals 5 times 1 plus 4. Therefore, the remainder, when 3 squared plus n is divided by 5, is the same as when 4 plus n is divided by 5, and depends on the value of n. Thus, let us look at condition 2, which tells us that n equals 1. Thus, the remainder, when 4 plus n, or 4 plus 1, that is 5, is divided by 5, will be 0, since 5 equals 5 times 1 plus 0. This condition has a unique answer, so this condition is sufficient by CMT 2, which states that the number of answers must be 1. Condition 1 tells us that m equals 1. However, we still cannot determine a unique value of n. So this condition is not sufficient by CMT 2, which states that the number of answers must be 1. Condition 2 alone is sufficient. Thus, B is the correct answer. The same pattern appears in the exam, so remember this. In particular, the answer to DS questions is often determined by modification, which is the first step of the variable approach. Generally, the condition without an exponent is the correct answer. In this question, B is the correct answer because n does not have an exponent. Answer B.